All right, here we go. I'm going to push this through to your Chromebooks for you. You're welcome. Also, so let's read this real quick. It says, when creating an animation, figures need to be translated, reflected, rotated, and sometimes dilated. As an example of this, applied the indicated sequence of transformations to this rectangle. Each transformation is applied to the image of the previous transformation and not the original figure. So what we're going to do is we start off with a rectangle, and we're going to do a bunch of stuff. Now, earlier today, I was talking to my students, and I was saying, when you play a video game and you run up to a building, it looks like you're running up to a building, but really what they're doing is just making the building bigger. When you look in a window and you see your own reflection on a video game, what they're doing is they're taking the image of the character and they're doing a reflection. They're just a mirror image of it. Your cell phones work the same way, right? Have you guys seen the filter, right? You know that when you take a selfie, it's the opposite direction, and now they have an app or filter that turns at the right side. That's why when you take a selfie, it always looks a little different, because it's a mirror image. Anyways, that's all done with math, right? The computers are programmed using math. So we're going to do what they said. So the first step here, I'm going to take my X and my Y, and I'm going to go 7 units to the right and 2 units down. So from here, I'm going to go over 7 and down 1, 2. Okay. And then I do that for all 4 of the points. So I'm going to go over 7. So 1, 2, 3, 4, 5, 6, 7, and down 2. And then same thing here. I'm going to go over 1, 2, 3, 4, 5, 6, 7. And then I'm going to connect the dots, and that's my first translation. So that is transformation A. Okay? You guys see what I did there? So I'll give you guys a second to write that down. Some of you will want to work ahead. Try not to. Try to just stick with Mr. Adams. Okay? So anyways, that's that. Let's do the next one. So now the next one, it says we're just going to negate the Y. So that is actually, that's a reflection, isn't it, across the x-axis? So wherever there's a Y value, I'm going to have the corresponding X value. So if I count 1, 2, 3, 4, I'm going to go 1, 2, 3, 4 in the opposite direction. Now if I do that with all of these, it's the mirror image across the x-axis. So we reflect it across the x-axis like this. And so that is step B. Step C, let's do that real quick. Crank that out. It says clockwise 90 degrees about the origin. And that's supposed to be my arrow. So that means I'm going to rotate 90 degrees this way. So this point right here is going to be this point right. Wait, let's see. It's 1, 2, 3, 4. So it's 1, 2, 3, 4. Yep. And then 1, 2, 3, 4 units away. And so now we're going to graph those. Now, rotations and reflections and translations are what we call rigid images. That's a fancy way of saying that the shape doesn't change. So this would be image C. Next, we're going to do, have I done green yet? Next, we're going to slide it to the right 5. So we're going to slide it to the right 5, and then slide it up 3. So from here, I'm going to go over 1, 2, 3, 4, 5. Then I'm going to go up 1, 2, 3. And then this one goes here. Then I'm going to go up 1, 2, 3. Wait. Go to the right 5. Oh yeah, I gotta go down. 1, 2, 3, 4. 1, 2, 3, 4. Connect the dots. So that would be D. Actually, you know, I've been doing this wrong the whole time. I could just draw the shape. Lastly, what I need to do from there, so that's that one. Now I'm going to multiply by 3. So I don't know, what color should I do that one? Let's do orange. So whatever this image is, I'm multiplying by 3. Yes? One is already orange? Oh, that's red. It might look like orange on the screen from where you're sitting, but it's red. It's okay. It does look kind of orange. It looks like a dark orange, doesn't it? Yeah. On my screen, it's red. If you look, well, you don't have your Chromebook in front of you. If you look on your screen, it looks red, but on the projector, it looks orange. You'll see here in a second. So this point here is 1, 2. So I'm going to multiply 1, 2. I'm going to multiply both those by 3, so I get 3, 6. So when I do that, if I go over 1, 2, 3, then I'm going to go up 6. I'll have a thing here. I'll have another one here if I do all these images. I'll have one here, and then one right here. And so now I'm just going to draw the shape. I think I could do, let's try this. Oh yeah, much better. So that whole thing in orange, that is the last transformation, E. It says, list the coordinates of the vertices of the rectangle E. So over here, I've got the coordinates 3, 6. Over here, I have negative 1, 2, 3, negative 3, 6. Down here, I have 3, 1, 2, 3, 4, 5, negative 5. Wait, that's negative 6, isn't it?
I think so.
Yeah, that's negative 6. I don't know where I got 5 from. And down here, this would be negative 3, negative 6. Yep, that's right. Okay. And if I wanted to write them all together, so I labeled them on the graph, but let's write them all together. So we've got 3, 6, 3, negative 6, negative 3, negative 6, and then lastly, negative 3, positive 6. It says, compare the following attributes of rectangle E to those of the original figure. Well, the shape, it's the same shape. It's still a rectangle, right? The size is larger by how much? 3 times. And the angle measures, those are all the same. They're all 90-degree angles on the inside of the corners. Okay, does anybody have any questions on that? So what I'm going to do is I'm going to leave this up for you guys to kind of jot down. If I went a little too fast, give you a chance to catch up. Once you're done with that, I want you to work on